Hello students, welcome to Educate. In the last class, we have discussed about nucleophilic addition reaction. In that reactions, I have given you 3 reactions in your homework. I hope all of you have solved these questions and have not felt any difficulty. But might be there be some students who felt difficulty or who have also not tried. By considering that, I am solving these 3 questions also. That means the nucleophilic addition reaction of these 3 compounds. That is phenylhydrazine. First one is that is we will have to react aldehyde or the ketone with phenylhydrazine. Reaction with hydrazine we have already watched. Now let's see reaction with phenylhydrazine. This one aldehyde or the ketone, and then after phenylhydrazine will be here phenyl group, means benzene here, and hydrazine means that is bonded to NH and here NH2. Okay. Now what happened? Same procedure as we have followed in the earlier reactions. One is here, same, oxygen will attack the pi electron, so there will be negative charge on the oxygen and the positive charge on carbon atom. Here, this nitrogen have a lone pair of electron. So this nitrogen will get attracted towards this carbon. So along with that, all of them will come. So structure will be this. Then after here to this one, same as in the earlier case was happening. Since this nitrogen have 2 electron, 1 lone pair of electron means 2 non-bonded electron. So this nitrogen will give 1 non-bonded electron to the carbon, and through other non-bonded electron it will do bond formation. So for this nitrogen there will be loss of 1 electron, as here the nitrogen has donated that electron to carbon and carbon has gained 1 electron. So the positive charge of the carbon, acylic carbon here, that will disappear. So here that has been disappeared here, but positive charge at the nitrogen. So to neutralize this positive charge, nitrogen will attract any one of the NH sigma electron. These 2 electrons will be get bonded here. So again this H plus ion released, that will combine to this oxygen. This H plus ion released, that will combine to this oxygen here. So what will be the product? It is this. Now reaction also you have seen there. Reaction will not stop here. There the lone pair of electron present at the nitrogen, that will come for the double bond formation. So the lone pair of electron present at the nitrogen, that will come here for the double bond formation. So what will happen that time? The hydrogen here, there is sigma electron at this nitrogen, so it will attract the pi electron here this side. That means from this side lone pair of electron go and here NH sigma electron come. So this H plus ion released, that will combine with this OH and will form H2O. So what will be there? H2O will form. So H2O will release from there. So then what will be the product here? There will be double bond here with nitrogen here and hydrogen have bond, and then after here is NH, and that is bonded to the benzene. It is it was phenylhydrazine. Hydrazine is bonded to the phenyl group, so that's why it's called phenylhydrazine. And after the reaction compound formed, that will be called phenylhydrazone. Okay, so it will compound will called phenyl. This compound will called phenylhydrazone. This compound is phenylhydrazine. It's also written here. Phenylhydrazine, reagent is phenylhydrazine and product will be phenylhydrazone. I hope you have not felt any difficulty. And the students who have practiced the reaction, who have not practiced also might felt easier to solve this question. Now let's see about the next reaction. Next reaction is reaction with 2,4-DNP reagent, 2,4-diphenylhydrazine. As in the phenylhydrazine, same reaction will be with 2,4-diphenylhydrazine. The product will be 2,4-diphenylhydrazone. Okay, I think it's very easy. It is here. Same 2,4-diphenylhydrazine. The structure will be house like here this aldehyde or the ketone that will react with 2,4-diphenylhydrazine. So here benzene here and NO2 will be at second position and at fourth position. So that's why here this one and hydrazine, so NH, NH2. Same procedure you already know, but okay, let's see how to prepare that and what is the use here will be here 2,4-diphenylhydrazine. This one is used to distinguish that the compound is aldehyde or the ketone. That means if 2,4-diphenylhydrazine will react with the 2,4-diphenylhydrazine will react with a compound, then that compound will be either aldehyde or the ketone. Okay, so the 2,4-diphenylhydrazine is used to distinguish that there is a acylic carbon or not. Okay, so about that you write that here its name is 2,4-diphenylhydrazine, same here, and its used to distinguish the compound okay. So let's see here, as there was the reaction same here, lone proton here, nitrogen, oxygen will take pi electron here, carbon positive charge, this nitrogen will get bonded to this carbon. So structure will be finally here NH. Directly I am writing because now you are habituated to do this reaction. But since this is important, that's why I am also doing this reaction. This one here. Now then after here from this side, here at H direct. Then after hydrogen will also release from here and will come into this OH. So double bond will form between this nitrogen and this carbon. So product will be that is this compound. So this compound will be called 2,4-diphenylhydrazone. As there was hydrazine converted to hydrazone, Same here, 2,4-diphenyl will convert into 2,4-diphenyl. So product is, it is here. Here written here already. 2,4-diphenyl. That is here. So that is, this product is 2,4-diphenyl. Semi-carbazide and semi-carbazone will form. No, I shall not do. You do that. If anyone feel difficulty, that means he have not studied well these chapters. Now then after is Clemmenser, okay, reduction. Reduction here, two types here you have to consider. As on number of time I have told you that when the alkane will get oxidized, then there will be formation of alcohol. When alcohol will get oxidized, there will be formation of aldehyde or the ketone. And when aldehyde or the ketone will get oxidized, there will be formation of carboxylic acid. That time also I have told you that 1 degree alcohol gives aldehyde, the 2 degree alcohol will give ketone, and the 3 degree alcohol will not react with mild oxidizing agent under normal circumstances. When the 3 degree alcohol will react with a strong oxidizing agent under vigorous condition, then the 3 degree alcohol will form carboxylic acid. Okay. So now same here it is. So if you will take mild oxidizing agent, then when you will take mild oxidizing agent, and here firstly is reduction. Okay. So reduction, same thing here. When you will reduce the aldehyde, there will be formation of 1 degree alcohol, and when you will reduce the ketone, there will be formation of 2 degree alcohol. Very simple it is. And when you will take very strong reducing agent to reduce the aldehyde or the ketone, then what will happen? The alcohol formed after the reduction of aldehyde or the ketone, that will further reduce into alkane. So depending on the reducing agent, there will be formation of alcohol or the alkane. Let's see here. So reducing agent, you know, CrO3, that is the oxidizing agent, like LiAlH4, NaBH4, they are reducing agent. So about that reaction, let's see. I have already taught you in the chapter of alcohol, but here I am just doing this aldehyde. Aldehyde is a stronger reducing agent than ketone, so that could be react with hydrogen also. Platinum, palladium, nickel, that will be used as a catalyst. This will provide the surface area for the hydrogen. So then after what happened? Same here, this hydrogen will bond to this oxygen, this hydrogen will bond to this carbon. So compound become Rosen-Mundt reduction. Keep in the mind, recall that Rosen-Mundt reduction. Now for the ketone, take the reducing agent like NaBH4. NaBH4. What's its name? NaBH4 is called, here it is sodium. So sodium borohydride. It is sodium borohydride. So NaBH4, that will dissociate to here. It will provide nascent hydrogen. So this hydrogen will bond to, because NaBH4, it will provide the nascent hydrogen. This nascent hydrogen. So this nascent hydrogen will bond to the oxygen, and some of the nascent hydrogen that will combine to this carbon. So product will be so 1 degree alcohol will form aldehyde. 1 degree that is aldehyde will form 1 degree alcohol. When the aldehyde will reduce, then there will be formation of 1 degree alcohol, and when ketone will reduce, there will be formation of 2 degree alcohol. And yes, it's a fact that aldehyde is more reactive than ketone. Then aldehyde will react with the H2 gas also. But the ketone will not react with the H2 gas. Okay, that was about the reduction here of that. And then after is about that was here the not so much a strong reducing agent taken. Then after is, if a special procedure will apply, if the special procedure will apply, then the aldehyde could also reduce directly into alkane. One example here is Clemenson reduction and another one is Wolff-Kishner reduction. So Clemenson reduction, what happened in Clemenson reaction? Here both aldehyde and ketone will undergo in Clemenson reduction as well as the Wolff-Kishner reduction. What happened in Clemenson reduction? Let's see here. Here H or NER. So what happened is this to this compound, this will firstly react with amalgamated zinc and conc HCl. Amalgamated zinc and conc HCl. Firstly, the aldehyde or ketone will react with amalgamated zinc and conc HCl. How is the amalgamated zinc? Zinc ribbon will be there, that will exist in the solid phase, zinc ribbon, and conc HCl. So when the zinc will be dipped firstly there in the conc HCl. Oh, sorry. Amalgamated zinc, amalgam means mercury. So mercury exists in the liquid phase, and zinc is just soft metals, and that will exist in the solid phase. Zinc will be solid, but that will be soft also. So zinc ribbon will dip in the mercury. So there will be formation of a film of mercury over the surface of the zinc. So that will be called amalgamated zinc or zinc amalgam. Now what happened? The zinc will react with conc HCl. So that will form ZnCl2. So nascent hydrogen will be provided from there. So nascent hydrogen will provide. So some of the nascent hydrogen will bond to the oxygen, and one nascent oxygen will bond to the oxygen, and one nascent oxygen will bond to this carbon. When the amalgamated zinc will mix with conc HCl, then firstly the zinc will react with conc HCl and the nascent hydrogen will provided. That of that nascent hydrogen, one nascent hydrogen will bond to the oxygen and one nascent oxygen to the carbon. But again that OH will combine to the hydrogen, because here this reaction will be very fast and very frequently the nascent hydrogen will be provided during the reaction. During this reaction, the nascent hydrogen will be provided very frequently. So the alcohol so formed will further reduce into alkane. So here this is of how much? 1, 2, 3 here. So there will be a formation of here 2 hydrogen will bond there, and that will be here either hydrogen or CH3. Depending on that. This reaction is called Clemenson reduction. Clemenson reduction written already. What is the role of amalgam? Here amalgam will prevent the formation of ZNO. So the amalgam will provide new surface area of the zinc for the reaction. The amalgam will here the amalgam, that means mercury, that will cause the availability of new zinc atom for the reaction. That will not let the formation of a protective covering of the zinc over the surface of zinc. So that is Clemenson reduction. That was okay. Then after is that was about the Clemenson reduction. Then after is Wolff-Kishner reduction. As by the Clemenson reduction, we have directly converted the aldehyde or the ketone into alkane. By the Wolff-Kishner reduction also, we will convert the aldehyde or the ketone directly into alkane. And what happened in Wolff-Kishner reduction? So first of all, the aldehyde or the ketone will reacted with hydrogen, and then after it will be treated with the mixture of KOH or the NaOH along with the ethylene glycol. Okay. So here NH2 about that, what's the product form? You already know. When the aldehyde or the ketone will react with hydrogen, what happen? About that you already know. Like suppose this ketone here or any aldehyde, whatever you would like. So NH2 is one here. You have studied there, so here already you are already aware how the reaction is taking place. That's why I am doing this reaction directly. So directly what was happening, both the hydrogen was combined with this oxygen and formed the H2O. So double bond will form between this carbon and this nitrogen. So compound become this compound will form here, and then after when the KOH will react with ethylene glycol. What's the structure of ethylene glycol? KOH here, and ethylene glycol, how the structure? CH2 here, OH, and here CH2OH. So potassium will directly react with that, and nascent hydrogen will provide it. This nascent hydrogen will provide it. So this group releases as N2. That azo group will release in the form of N2. So this N2, so that this carbon will satisfy its valency by absorbing the hydrogen. So the product will be that is here. That is Wolff-Kishner reduction. In the Wolff-Kishner reduction, we react the aldehyde or the ketone with firstly hydrogen, and when we react the hydrogen, so product form, and then after that intermediate so formed will be treated with the mixture of KOH and the ethylene glycol. As a result, the aldehyde will be converted into the aldehyde will convert into the alkane. That was about Wolff-Kishner reduction. So keep in the mind here Wolff-Kishner reduction and Clemenza reduction. That is very important for you. Then after, let's see about the oxidation. Oxidation here, what is that? In oxidation, as you know, aldehyde is more reactive than ketone. So oxidation here can be used to distinguish the aldehyde from ketone. The oxidation of aldehyde or the ketone, that can be used to distinguish that the compound is aldehyde or the ketone. As aldehyde is more reactive than ketone, that's why aldehyde will react with mild oxidizing agent, but the ketone will not react with mild oxidizing agent. That will react only with a strong oxidizing agent and under vigorous condition. As aldehyde is more reactive than ketone, that's why aldehyde will react with mild oxidizing agent also. But the ketone is not so much reactive. That's why it will react with the strong oxidizing agent only, and that will be also under vigorous condition. Okay, so what here? The Tollens reagent, very important here is the Tollens reagent and the failing solution. Tollens reagent and the failing solution. What is Tollens reagent? Ammonical silver nitrate is called Tollens reagent, commonly called ammonical silver nitrate. Means silver nitrate that will dissolve in what? In ammonia. Here silver nitrate, firstly how the Tollens reagent will prepare? Silver nitrate that will dissolve in ammonia. What happens? Silver is a transition metal, d block element. There is vacant d orbital silver have, but the vacant d orbital is only 2. Number of vacant d orbital in silver here is only 2. Draw the structure, resonant structure like silver here. In +1 oxidation state, what will be there? Firstly, there is an electron, okay. So one electron will reach from here and one electron from here. So now what happened? Silver nitrate here, that will, when ammonia will dissolve there, so ammonia will donate their lone pair photon to the silver here, that become AgNH3 whole twice, and then after here NO3, that can be also written as AgNH3 whole twice, and here plus charge. This one is Tollin's reagent. This one is Tollin's reagent. The aldehyde can react with this Tollin's reagent, but because Tollin's reagent is a mild oxidizing agent, so aldehyde will react with the Tollin's reagent, but ketone will not react with the Tollin's reagent. So let's see here. So what's this one is how Tollin's reagent is formed. Then after is aldehyde when react with Tollin's reagent here given, Tollin's test here. Here aldehyde, this one, that is reacting with the Tollin's reagent. This is aldehyde here with Tollin's reagent in presence of alkaline medium here. What happened in presence of alkaline medium? This compound is Tollin's reagent, and in alkaline medium, the Tollin's reagent oxidizes the aldehyde into oxalate ion, and the silver will get precipitated down here. The silver will get precipitated down, and this precipitated silver, that means you just imagine small particles of silver will just precipitated at the bottom of the vessel. So that will shines like a mirror. So that's the reason here this test is also called silver mirror test. That's the reason the Tollin's test is also called silver mirror test, because when Tollin's reagent react with aldehyde, the silver atoms will get precipitated at the sulfur, and that will shines like a mirror. So the Tollin's test is also called silver mirror test. Okay. Then after this here, reaction with Fehling's reagent. Fehling solution, that is of two types here. How to form here? Fehling solution A and Fehling solution B. In Fehling solution A is copper sulfate, and Fehling solution B is at a alkaline sodium potassium tartarate, or that is also called Rochelle salt. Both be mixed together, and there will be formation of Cu2 plus, and it is actually Fehling's reagent. Fehling's reagent here too, that is Fehling solution A and Fehling solution B. Before testing the reactions, firstly we will mix the Fehling solution A with the Fehling solution B. What is Fehling solution A? The CuSO4 solution. CuSO4 solution is called Fehling solution A, and the alkaline sodium potassium tartarate, that will be called Fehling solution B. Before to test the reactions, we will have to firstly mix the Fehling solution A with Fehling solution B, and then after we will have to perform the reaction. So during that course, what happened? The Cu2 plus will act as oxidizing agent. Cu2 plus will act as oxidizing agent. So that will reduce into Cu plus, as Cu2 plus is an oxidizing agent. That's why it will oxidize to aldehyde into carboxylate ion, but will reduce into Cu plus, that is Cu2O. So this Cu2O will be red brown and it will be insoluble in water. This Cu2O is too much less soluble in water. Cu2O is too much less soluble in water, and that is red brown color also. So that's why during fairing test, red brown color of Cu2O will precipitate. So we will obtain the red brown precipitate of Cu2O. So this reaction could be used to distinguish aldehyde from the ketone. Aldehyde will react with failing solution and will give a red precipitate of Cu2O. But the ketone will not react with failing solution and that will not give red precipitate of Cu2O. Okay, as in the tolerance test, what will happen in tolerance test? When the ammonical silver nitrate, that is tolerance reagent, will treat with aldehyde, at the bottom there will be substances which will shine like a mirror, and that means if there is mirror shining at the bottom, that means that compound is aldehyde. But if there be no reaction, so nothing will shine inside the vessels, so that will be maybe ketone. And if it has been predicted that the compound is containing acylic carbon, so that means that is either aldehyde or the ketone. Okay, that is here. Then after here is haloform reaction. Haloform reaction. What is here? Haloform reaction. Haloform reaction is used to determine that there is a methyl group bonded to the acylic carbon or not. That means those compound will show haloform test. Those compound will perform the haloform test in which there will be a methyl group bonded to acylic carbon. In other words, those aldehyde or ketone will perform the haloform test in which there will be a methyl group bonded to acylic carbon. Okay, and particularly we will hear haloform test most frequently is iodoform test. Okay, so iodoform, this one is of versatile color, that may be yellow, that may be red, that may be of orange color. So that is here. So when there will be formation of chloroform or the iodoform, when haloform, that will be red or yellow or of orange color. Okay, so let's see here. What about the haloform test? What is here? Suppose this compound here, this aldehyde will not show haloform test because there is no methyl group bonded to the acylic carbon. Okay, frequently asked question in IIT main and in NEET examination both, that which of the following compound will show haloform test. One is that. Second one type, which of the following compound will show aldol condensation reaction. So that's also we will discuss about that. And third one is also that which of the following compound will perform the Kane-Jarrow reaction. So all the three concepts. So here for the haloform test, keep in the mind there should be a methyl group adjacent to the, there should be a methyl group bond adjacent to that methyl group bonded to the acylic carbon atom. So that compound will give haloform test. Okay, this compound will give this compound will not give. In the same way, in this here benzene, C double bond OH. Here also no methyl group, so it will not show haloform test. It will not show haloform test. Now another aldehyde, if we take CH3, C double bond OH, so it will perform the haloform test because there is a methyl group bonded to the acylic carbon. So that means ethanol will show the haloform test because there is a methyl group bonded to acylic carbon. Okay. Then after is here, if the compound will be, so this compound will not show haloform test because there is a ethyl group bonded to the acylic carbon and not the methyl group. So this compound will also not show haloform test. Okay. So let's see here what happened in the haloform test. Suppose this compound you have taken. In the same way, other reactions will be there. So you do by yourself. How the sodium hypoiodide is formed? Haloform test. NaOH when reacts with iodine. So there will be formation of NaOI. It is called sodium hypoiodide. Sodium hypoiodide. So this compound directly react with either sodium hypoiodide or the mixture of NaOH and I2. Because when the NaOH will be bonded to the iodine, there same here there will be formation of NaOI. What happened during the reaction? The methyl carbon bonded, the methyl group bonded to the carbon atom, that will oxidize into CHI3, and this whole portion will oxidize into their carboxylic ion. So HC double bond O minus, that is here, or O minus or Na, whatever be that here, Na. So sodium carboxylate will form and iodoform will form. Here it will be red or whatever be that, depending on the compound. So the red or orange or yellow colored this precipitate will form. So when there will be precipitate of this red or orange or of yellow, then this compound will contain a methyl group bonded to the acylic carbon. Okay, so you may write the haloform test is used to distinguish this group. This group, very important, that's right there. That's the haloform test is used to distinguish this group. Okay. About this question we will discuss later on. In the next class we will discuss. Firstly, I would like to complete the reactions of this chapter. Then after is aldol condensation reaction. Two more very important reactions here is aldol condensation reaction. The aldol condensation reaction will perform by those aldehyde or the ketone. The aldol condensation reaction will perform by those aldehyde or the ketone which contain alpha hydrogen. Alpha hydrogen might be, that recall that the carbon atom to which the functional group will be bonded, that will be called alpha carbon, and the hydrogen bonded to the alpha carbon will be called alpha hydrogen. That means aldehyde or ketone having alpha hydrogen will show aldol condensation reaction. Let's see here how the reaction is taking place. Let's see here. As for example here, just take this compound will show aldol condensation reaction because there is alpha carbon and here alpha hydrogen. But this carbon, this aldehyde, methanol, that will not show aldol condensation reaction. The methanol will not show aldol condensation reaction because there is no any alpha hydrogen. This hydrogen is not the alpha hydrogen. That's why the methanol will not show aldol condensation reaction. In the same way here, ethanol here, that can show aldol condensation reaction because this is alpha carbon. Here there is hydrogen. So alpha hydrogen is present in this aldehyde. That's why this compound, this aldehyde will show aldol condensation reaction. Okay. So how the reaction is taking place? Let's see here. Aldehyde methanol I am writing here in the expanded form. What happened during aldol condensation reaction? What happened during aldol condensation reaction? Let's see. This oxygen will take the pi electron here, negative charge, here positive charge. Now to neutralize this same here, to neutralize this positive charge, the sigma electron can come to this here double bond also. So there will be abundance of hydrogen. This H plus can be there, this H plus can be there, this H plus can be there. So the hydrogen bond of the bonded to the alpha carbon, that maybe comes in the form of H plus. So this H plus may combine in the same way here also. What happened? This oxygen will take here negative, here positive, and here positive, positive, positive. So either the hydrogen of this carbon will go to this oxygen, or the hydrogen of this carbon, this one will go to this oxygen. So hydrogen of this hydrogen will go to this oxygen, or this hydrogen will go to this oxygen. That will depend on the method of chance. So whatever be there, same here reactions will be accordingly to that. But hydrogen of any alpha hydrogen of one alpha hydrogen of one aldehyde can go to the other one here, and from which molecule to which molecule, that will the H plus will go. That will depend on the method of chance. Let's see here. So as you know here, that will go I am considering that this hydrogen go to this oxygen. So what happened? This will become, here is CH3, it become CH and OH. When the hydrogen will bond to that oxygen, so there will be single bonding between the carbon and the hydrogen. There will be single bond formation between carbon and hydrogen. So what will happen? The valency of this carbon atom become destabilized, and when hydrogen have gone from this carbon, then the valency of this carbon atom will also become unsatisfied. So this carbon here that will get bonded to this carbon. So here will be this is called aldol. Why it called aldol? Because in this molecule there is an aldehyde group as well as the alcoholic group. In this molecule there is an aldehyde group as well as hydroxyl group or alcoholic group. So that's why this compound is called aldol. And then after there will be elimination reaction. Now when there will be elimination reaction, so hydrogen will release from beta carbon. This carbon is beta carbon and this carbon is also beta carbon. Recall that Marconi-Sadyev's rule. So hydrogen released from that carbon atom which will contain less number of hydrogen. So this OH will bond to the hydrogen of this carbon, form H2O, and double bond will form between both the carbon atom to satisfy their valency. So the structure will be that is one aldol condensation product. Okay, aldol and aldol condensation product, that is. But ketone, in ketone also there is formation of here same compound, but reagent usually we take BaOH whole twice, barium hydroxide. Here for the aldol condensation reaction in aldehyde, dilute NaOH is taken, but for the condensation of barium hydroxide, or that is for the aldol condensation reaction in ketone, the barium hydroxide will have to take. Okay, one reactions what you will have to do in your homework, that is you will have to do the aldol condensation reaction in propanol. That will be your homework. The aldol condensation reaction you will have to perform in propanol. Okay, firstly you try your best at your home, then after I shall discuss in the next video. Then after is aldol condensation, cross aldol condensation reaction. What happened in cross aldol condensation reaction? Two different molecules, two different types of aldehyde will be taken. One suppose ethanol, methanol here one ethanol, and one suppose taken propanol. That react with NaOH. That react with dilute NaOH. So what happened? In first case, the hydrogen of this carbon may go to this oxygen. So in that case, what will happen? So this carbon will bond to this carbon. So this carbon will bond to this carbon. So now consider about this one. It is CH, and this CH is bonded to CHO in one side, and to other side it is bonded to CH3. And then after there will be condensation reaction. Then after second one is that the hydrogen of this carbon may also go to this carbon, this oxygen. Hydrogen of this carbon may go to this oxygen. So that become, then after this carbon will bond to this carbon. So what will be the structure? CH3, CH2, and it becomes CHOH. So then after there will be and this carbon will get bond to this carbon. So here will be CH2, and here second is that. Now in third one is there will be aldol condensation reaction in methanol also. So this here and here also. About that, right now we have discussed. So this hydrogen go to this oxygen structure. Third one is that. So third one will be and fourth one same. That means there is a reaction, there is transfer of hydrogen from propane, that means the hydrogen, alpha hydrogen, from the propanol to ethanol. Same, some product will form by the transfer of hydrogen from the ethanol to the propanol. In the same way, there will be transfer of electron between the ethanol molecules. So one ethanol will come here, one ethanol. So this product will form. In the same way, the propanol, among the propanol will be also there. The transfer of electron, like this one, transfer of hydrogen. So this one. So what happens? Suppose hydrogen goes from here to here, or here to here, doesn't matter. Product will be same. So that will be, structure will be what? And when I go to this one, so this carbon will bond to this carbon, and this carbon is bonded to the methyl part in one side, and the CHO group in another side. That is here. So another product will be that is here. And after that, what's the condensation? You do by yourself. Okay. Then after is Kenny-Jarrow reaction. Kenny-Jarrow reaction. What happened in Kenny-Jarrow reaction? Kenny-Jarrow reaction will be performed by those aldehyde which don't contain alpha hydrogen. So here, like this compound methanol, it will here no alpha hydrogen, so that will show the Kenny-Jarrow reaction. And here in that one compound will get oxidized and one compound will get reduced. So that means the Kenny-Jarrow reaction is a type of disproportionation reaction, and in that one aldehyde will reduce into their alcohol and as well as into their carbonylate ion. So here the aldehyde group, that means aldehyde not containing the alpha hydrogen, that will reduce into their carbonylate ion and will reduce into alcohol. Same here benzaldehyde here. This benzaldehyde when react with CONC-NaOH, it can show the Kenny-Jarrow reaction because this carbon is alpha hydrogen carbon and here is no hydrogen. So it can show Kenny-Jarrow reaction. It will oxidize into sodium benzoate and reduce into benzyl alcohol. Okay. Next one is electrophilic substitution reaction. So what happened in electrophilic substitution reaction? The CHO is a electron withdrawing group. CHO is an electron withdrawing group. It will go, that means the electron, it will take the electron of benzene. So it will give position to the electrophile at meta site. So that's why this one will form. That was about the reactions performed by the aldehyde and the ketone. In the next class, we will discuss about few important topics related to the chapter aldehyde and ketone. It's all for this class. Thank you, Team Educate.